Okay, this notes are on writing quadratic equations. And so for the warm-up, the first question asks for the vertex. And this equation is in vertex form. And so we can get the vertex by taking the opposite of what's with x as our x coordinate, and then taking this number exactly as it is as our y coordinate. So if you were to graph this in Desmos, it would show you the vertex is 5, 7. This next one asks for the solutions, and this equation is in root form, which means we take the opposite of what's with x. So in this case, 3 and -1 would be our roots. And so our solutions would be 3 and -1. Roots and solutions are the same thing. They refer to the x-intercepts. And so if you were to graph it, you would see -1 and 3 as those x-intercepts. Okay, last class we converted vertex form to standard form, and so we're going to practice that. Okay, and so the first thing you want to do is I like to rewrite the x minus 5 squared as x minus 5 times x minus 5. And then we need to take care of that by making a box. Okay, so x minus 5 times x minus 5 is x squared minus 5x minus 5x positive 25. These are our like terms, which add to -10x. So the result of the box is x squared minus 10x plus 25. Put that back in parentheses and bring down the 2 and the plus 7. You have to distribute the 2 next, which would give us 2x squared minus 20x plus 50. And then your last step is to combine these last terms. And so we would get 2x squared minus 20x plus 57 as our final answer. And so this is our standard form. We can see that A is 2, B is -20, C is 57. Here we're starting with root form. And so I start by making the box for our two binomials, x minus 3 times x plus 1. Gives me x squared 1x -3x -3. Our like terms, -3 plus 1 is -2. And so the result of the box is x squared minus 2x minus 3. Put that back in parentheses and bring down your -4. And then distribute your -4. Positive 8x plus 12. And so that would be our standard form. And so A would be -4, B would be 8, C would be 12. Okay, so as a review, standard form tells us what our A, B, and C value is. But vertex form, we get the vertex for free from the equation. It's the opposite of what's with x, and then the number outside the parentheses for the vertex. And then for root form, we have opposite of the roots. And those roots are also called solutions, or x-intercepts, or zeros. Oops. All right, and so we're going to need these to write our equation because they're going to give us information. So starting with number 1, we want the standard form. Okay, and so standard form is ax squared plus bx plus c. And they're telling us that the zeros are -5 and -3. And so we know our root form, zeros are the same as roots, would be y equals some a value we don't know, x plus 5, x plus 3, because we had to take the opposite and put them inside the parentheses. And so it also says it goes through this point, 348. That's an x and a y that we can plug in. Y is 48 when the x is 3. We're going to plug those in just so we can solve for what this a value is. Okay, and so 48 equals a. 3 plus 5 is 8. 3 plus 3 is 6. And so 8 times 6 is 48. And that's being multiplied by the a. And so to solve for the a, I just divide by that 48, both sides. 48 divided by 48 is 1. And so my a value is 1. Okay, and so in root form, the equation is y equals 1 times x plus 5, x plus 3. And usually they won't write the 1, so I'm just going to delete it. And so to convert it to standard form, we just make a box. X plus 5, x plus 3, x squared, 3x, x 15. Combine our like terms, we get 8x. And so our standard form would be x squared plus 8x plus 15. And that would be our final answer. So A would be 1, B would be 8, C would be 15. Okay, on this next one, it says a single solution of -8. So that means that factor is repeated. And so remember, solutions are also another name for roots. And so our root form would be y equals a. I don't know what a is. And then we would have that x plus 8. And we would actually have it written twice since it's a single solution. Okay, and then they're giving us this random point we can plug in for y and x. So x is -1, y is 98. So 98 equals a. -1 plus 8 is 7. 7 times 7 is 49. And it's still being multiplied by the a. Then we can divide by the 49. And that would be 2. So we know our a value is 2. And so our root form is 2x plus 8, x plus 8. And we can convert that by making a box. So we get x squared, 8x, 8x, 64. We can add our like terms. We get 16x. So x squared plus 16x plus 64. Put it back in parentheses. Bring down the 2 and distribute it. We get y equals 2x squared plus 32x plus 128. And that would be our standard form. And so a equals 2, b equals 32, c equals 128. Number 3, similar, so I'm going to skip to number 5. This time, they're giving us the vertex. Okay, and so we have to start with vertex form, which is y equals a, x, and then opposite of x would be plus 1 squared, and then the minus 12 would be outside. And then we have a random x and y we can plug in. So y is negative 10 when the x is 0. Okay. 0 plus 1 is just 1. And then 1 squared is just 1. And that's being multiplied by a. Okay, so we're trying to isolate the a term, so we need to add the 12 to both sides, which would give me 2 equals a times 1. Then you can divide by the 1, so a equals 2. And so I know my vertex form has a 2 for the a value. And so now it looks like this. And then we can convert it to standard form. I like to rewrite it as x plus 1, x plus 1. We need to make a box for the x plus 1 times x plus 1. Our like terms, add to 2x. So we get x squared plus 2x plus 1. Put it back in parentheses and bring down your 2 and your minus 12. Distribute the 2, 2x squared plus 4x plus 2, and then combine. 2 minus 12 is negative 10. So that's our standard form. A is 2, B is 4, C is negative 10.